we're checking the evens. We've actually already gone through almost all of them, so if you're watching this at some later point, go ahead and pause it and check. Number 4, check. Number 18? Check it. They don't agree. Limit D and E. Number next one, 32? Function is not continuous. The limit works. The function works, but they do not agree. Number next one, 38? The limit does not exist because from one side of the vertical asymptote, non-removable discontinuity, it's going to infinity. From the other side, negative infinity. The limit does not exist. It's a non-removable discontinuity. Number next one. Okay, now we're all caught up. Wait a minute. Why is it non-removable at 3 and removable at -2? Yeah, -2 is a whole, by definition removable, and at 3 doesn't cancel out. So therefore, by definition, non-removable. At -2 is a whole, hence removable. At 3 is a vertical asymptote, hence non-removable. Number next one. What was it? 54. Oh, this is 51. I was so confused. Non-removable, but for K. Does the function exist?
Yes.
Yes. At 2, we plug into the top, which would be -4. Does the limit from below exist? Yes. Does the limit from above exist? Yes. Plug in the separators, but what happened when you plugged in the separators?
Jump.
They did not agree. Yes, there is a, did I call it a jump or a break? That's a break, right?
Oh well, same thing.
Either way, there's the two one-sided limits do not agree, therefore non-removable discontinuity. Number next one.
66.
Yes.
These ones were fun.
But you factored the numerator, x plus a, x minus a, cancel out the x minus a's and plug it in.
Oh.
Find the limit by factoring the difference of squares. Cancel out the x minus a's, you have x plus a left. Plug it in. The limit is 2a. They said make it continuous. So take the limit of the function. I think this was a weird piecewise one, right? Is that why you guys didn't like it?
It was just weird because of the non-equal sign.
Yeah. They showed it to you a little funny. They had a not equals and they had an equals. True?
Yeah.
And I said this one was 8. This tells me about a limit or about a function value. This bottom piece. It's a function value. Exactly. F of A equals 8. That's what this piece tells me. F of A equals 8. So what are we going to use this piece for? The limit. Because if I were to go a little bit below A, wouldn't it be in here? And a little bit above A would be in here too. Everything but A is this. So we just take the limit of that. No big deal. We don't even have to worry about two different pieces for below and above. Just take the limit of this guy. Cancel out the x minus A. Plug it in. That's the limit. This is the function. Set them equal and... Does that make sense?
Can you set them equal from the get-go?
Well, not the function though. Because if you set the function equal to this, you're going to have x minus a. We have to take the limit as x approaches a. We need to plug in a first.
Okay.
Does that make sense? And technically it's illegal to plug in a right now. It's 0 over 0, keep going, so we had to factor it first. That's why the limit notation is easiest. Kiddos, any more evens?
102.
Any more beyond that? Okay. Number 102, then we're going to section 6. This is the intermediate value theorem. I know you didn't have to write it in your forever quiz today. Doesn't mean you were supposed to have it memorized. They gave us an A, they gave us a B. We were supposed to find f of A and f of B. Because according to the theorem, if f is continuous, wait, no, he's not continuous. Whole thing fails. Except, where's the discontinuity? At 1. Is 1 in between A and B? No, this is 2.5 to 4. So is f continuous on A to B?
Yes.
Yeah, so even though the function is discontinuous at 1, it doesn't have any bearing on my interval. So, as long as f is continuous on A to B, and if there is a y value in between f of a and f of b, then there must be some c within a to b such that f of c equals k. So the one they gave us was, hey, what about 6? Is 6 in between 35/6 and 23rds? Because this would be 5 something, right? 5 and 5/6. This one is 6 and 2/3. Is 6 in between? And the answer is yes. Therefore, since f is continuous, since the y value they're asking about is in between f of a and f of b, we say IBT applies. And by IBT, we can say, hey, let's go ahead and take our function, set it equal to 6, and there must be at least one guaranteed x value in between the interval. What's the only one in between?
3. Okay.
Just 3. So 3 is our guaranteed c. 3 is our guaranteed c. Does that make sense? Had to find f of a, had to find f of b, had to show that 6 was in between. And then we went ahead and set. Alright, kiddos, section 1.6. Let's go fast. Help me with the evens once again. What's the first one as I get there?
4, 6.
Wait, 4, 6, 2? I'm so confused.
4, 6.
Oh, thank you. Alright. 2 should be C. 2 should be C. 4 should be A. 6 should be E. 2 should be C. 4 should be A. 6 should be E. Number next one.
10.
Number 10. Final answer is 0.
14.
Because it's getting smaller and smaller and smaller and smaller. 14. Final answers. Negative infinity. Best answer. Negative 4 and 0. Negative infinity. Negative 4 and 0. Number next one.
24.
1/2.
28.
It's okay. 1/2. You guys got it?
Yeah.
Okay, 28. D, N, E. Or best answer is infinity. Best answer is positive infinity. Number next one.
30.
0. 0. Bottom one. Next one.
36.
Don't worry about the note. They're trying to explain to you another way of thinking about it. The final answer is 1. Quick question on this one. Quick question on this one. Who is stronger as a graph as far as the y values as you go to positive infinity without bound? X or cosine? Who's stronger? X. His values are higher. So as you're looking at x and at cosine, whose degree is higher? X. Because who goes higher? X. So we just need to test the highest degree at the top, highest degree at the bottom, the ratio of these. Does that make sense, kind of, guys? Cosine and sine are very weak. They're always very weak when we're going to infinity. They only go between 1 and negative 1. That's what all this snazziness is talking about. Number next one.
44.
4.
That's so weird. They like, why do you...
I don't even understand. Like, I said that you can't
Don't worry, don't
because
worry.
they tried
Don't worry.
rationalizing with different numbers. It
Don't
was
worry.
weird.
What they're doing is that they're trying to take away the degrees. And so when you divide the top by x, it's just 4. But isn't x and the square root of x squared the same thing?
Yes.
But I needed the square root of x squared to bring it in. Anyway, long story short, question. Whose degree was stronger?
The same.
It's the same because the square root of a squared is linear. So since the degree is the same, we say you take the ratio of leading coefficients, which would be 4 over, I say plus or minus 1, I say you better check the sign. We're not actually square rooting x squared plus 8, but what we are saying is, as we go to infinity, the 8 is inconsequential, the x squared takes over, and we worry about his coefficient, so we're just square rooting the 1. Technically think plus or minus, check the sign, but if you plug in a positive up here, isn't this a positive? Yeah. Plug in a positive down here, square plus 8 square root, isn't that a positive? So keep it positive 4 over 1 then. If that was a 2x squared, it would be positive 4 over root 2. So they're showing extra work. That's true, but that doesn't necessarily need to be your work. The degree tests work as long as you're careful. Anything else?
48.
This one was a little bit of a weird one. Did you guys look at the graph on here? It is plus or minus 3. They ask for a horizontal asymptote, which means we're going to, you've seen maybe now for the first time, sometimes when you go to infinity and negative infinity, you get different answers. So sometimes there's more than one horizontal asymptote. How can we figure that out? Guys, degrees, who wins? They're the same, because the square root of a quadratic is a linear. Does that make sense to everybody? Okay. So if we were able to square root, this would be a first power. So they're the same. So we say the limit is, or the horizontal asymptote is, we have to check plus or minus square root of 9 over 2. We have to check these. We have to check the sign. Kind of like we check with plus or minus infinity with number over 0. We have to check the sign. So if we were to go to positive infinity, if we plugged in a big, huge positive number squared times 9 minus 2 square rooted,
Positive.
that's a positive. If we were to plug in a positive times 2 plus 1, what would that be?
Positive.
A positive. So it's a positive over a positive 3/2. Done. But if we were to plug in negative infinity, squared times 9 minus 2 square rooted, what sign would that be?
Positive.
But what sign would this be? Bigger and bigger than negative. So this would be a positive over a negative 3/2, which is why I have 2 answers. If they're asking for a horizontal asymptote, they're not just asking for one infinity, they're asking theoretically for both. Usually they're the same number, so we just give one answer. But do you see how sometimes it could give 2 answers? Gotta be aware. Gotta be watching out for what might happen. Do we have any more evens?
No.
No? Okay. Let me see real quick what's going on. Your guys' homework sheet is here somewhere. I do have a test review, right?
Yes.
Let's go check it out. We're in why was I going to chapter 6? We're in chapter 1.
What's chapter 6 on?
That's the end.
What? There's only 6 chapters?
Volumes, discs, and washers. Yeah, but I cut chapter 2 in half. I cut chapter 5 in half. And we have like a month of AP practice-ish. Which we do AP practice throughout. All right, let me see. We have a good amount of review problems, yeah?
That's right. How long is the book? 6 chapters?
No, our book has Calc 1 and Calc 2.
Oh.
So it keeps going for quite a while. Test review.
What does it mean?
Okay. Kiddos, with the remainder of class, let's do this. I have some great practice problems that would be really fun. Maybe fun's not the right way of wording it. That would be really beneficial for us to do with whiteboards and groups on Monday before the test. So let's have it be Tuesday for those people with the ACT, but I need you guys to listen to me really carefully. We are going to go ahead and do in our workspace those other practice APs that you guys didn't get to yesterday. So we're going to get the back of your styles ready. But I need you guys to listen to something real quick. Some of you, I could tell by what we were grading or not grading today, are behind. And that's okay, because you have a weekend if you use it right. So those of you that have not done section 1.6 or any other sections before that, I question your commitment if you haven't done any other sections besides 6. And that's not in a way that I'm judging, it's in a way that I'm just trying to help you and say, it's scary if you are missing anything besides 1.6. But this weekend, you need to say, if you want this, if you want to be committed to calculus, you need to catch up on your homework. Now, for those of you guys that are like, I was ready to grade 1.6, or even for those who are like, I'm going to catch up and start reviewing, work on your test review this weekend. In class, we're not doing these problems. I'll go over questions. We'll, you guys saw the answer key, right?
Yeah.
I have the answer key at the end of the notes. I have the answers to the review. So if you want, like, some of them are odds, some of them are evens. I think they actually might all be in the back of the book, but do you guys see how I have the worked out CalcChat versions of the odds and the evens to the review? Use that. Try the review, go check it. Grade it before you even come to class, and these are the questions I have. I know any time remaining we'll go to these practice problems that I have that we can do in groups. So don't work on these. Just get to the end, come to the answers after you're able to attempt the review. Sarah?
To find the worked out answers on CalcChat, do you have to like put a code in or anything?
No, you shouldn't have to. You just type CalcChat and you have to find your textbook.
And then what do you do after?
You click view. Hold on, let me help real fast. It's just like pre-cal, it's very similar.
I tried to use it and I couldn't.
Are you okay? Were you looking for the video solutions or were you looking for...
Like just the worked out version.
Actually, let me also do this because there's actually a website just for our book. What's it called? There's a website just for our book too.
I think you have a link to it too. On your website.
Yeah, I do, right? Okay, hold on. But let me also go to CalcChat. If you just go to CalcChat, the other one is called CalcView. If you don't have a QR reader and you don't download the CalcView, CalcChat apps, there are apps that might help.
I wonder what CalcChat looks like. Oh.
They have updated it a little bit. It's Calc for AP First Edition, then you hit View. And then you just need to go to whatever section, whatever chapter, whatever exercise you want, and then just hit Go.
Exercise like a problem number?
And then this guy, there are online assistants ready to go.
So this is where we go to like check the review.
Okay, I think
Well, to check any odd of any section.
Okay.
Do you know what I mean?
What about like the evens of the review? Do you want us to correct those after we talk them?
Well, the evens, I've pasted this in the notes. So I'm going to save the notes online, chapter 1 notes on my website, your class folder. At the very end of our notes, see, I'm just in notes right now. I have saved this so you can check it beforehand to come with questions on Monday.
Okay.
Does that make sense? And with any extra time that I hope we have remaining, we'll just do practice problems together. Does that sound good? Okay. So there's lots of ways of practicing, guys. It's the best way I know for you to get proficient at math. I think Helpful Links is where I have our...
I think that
Here it
takes
is.
us to the wrong place.
Oh, does it?
Like, it takes you to the right place, but you can't like access the actual answers to that one.
Oh, this one has CalcView. If you want it, it has just click on it.
What?
Click on it. So this one has the videos for each of those ones that are pink with the QR codes, so you can get to the videos for each of them. But if you want to get to like the exercise, go to actual CalcChat or go to actual CalcView. Does that make sense?
Okay.
So just use it as a place to have the links to all the things that you want to go to. Does that make sense, kind of?
Yeah.
Okay. And if you guys want, you can download the apps, and I think there's a QR reader in the app. Has anybody downloaded CalcView?
Can you download this CalcChat?
Yeah, there's a CalcChat app and a CalcView app. So if you don't want to have to go looking for it, that might make it a little bit easier. All right, cool kids. In the back of your notebooks, let's do workspace. Are we okay on what we're supposed to do this weekend?
One question about the review. You don't have to write down the directions.
Oh, for those of you that didn't have me for pre-calculus or didn't have me last year or weren't here last year, for the reviews only, do not write directions, do not write the problems, just go. Just see if you can get it done. So that's to save you time, like just practice. As though it's a test, you wouldn't have to write the questions on the test, just practice and see if you can get it right. So don't worry about directions or problems on reviews only. Where's the review going to go, even though it's not a homework number?
In your spiral.
In your spiral, right after homework 6. So what am I collecting on Tuesday? Your notes and your spirals. But please catch up this weekend, because if you don't, next week is really going to hurt. Okay? Your test on Tuesday.
Oh.
Your test on Tuesday is really going to hurt. Please catch up, be ready for Monday so that you are already on the top of your game and I can just polish and get you a little bit higher. Does that make sense? If you come in Monday being like, I don't know what's going on, I can't get you to a mastery in a day. I can't do that. I can, if I was tutoring, maybe, but probably not. All right, cool kids, here we go. Back of your spiral. Let's play around with some exam prep. You do not have to write the whole question, but if there is something like a function or whatnot, that might be helpful. Oh, I'm sorry, this is 1.6 AP practice or NC practice or whatever you want to call it. This is 1.6. Alright. Do your best. I'll do 4 minutes for 4 questions. I won't call it horizontal asymptote, I'm gonna call it limits to infinity, parentheses, HA. And this one is not a lot of work to show. Yes!
I got it right.
Because the limit is infinite. Alright, for sake of time, I want us to have time to talk through them. So hopefully you were able to at least get 2 or 3, if not all 4. How many of you have an answer, a hypothesis for all 4? For at least 3.
I'm almost there with 3.
For at least 3 of them, for at least 2 of them, for at least 1 of them. Hold on. Everyone's hand should be up.
Yes,
One,
yes.
unless you don't have one answer.
Sorry.
Okay. It's okay. We're still learning the whole English thing. Alright, so 77.
Whoa, sad.
It's okay. People always make fun of me. You don't need to know English. You're a math teacher, right? That's no excuse. It's almost an English teacher. Alright, C. C. Number 78. You guys know, just by definition, the limit to infinity has to equal to a constant, right?
Why is it defined?
Because a horizontal asymptote means as the graph goes to infinity, it needs to be approaching, the limit needs to be approaching. As x goes to infinity, the function needs to be approaching that horizontal line. The limit to infinity of a function has to equal 10. Otherwise, the horizontal asymptote will not exist. No, because horizontal asymptotes, I know why you're saying that, but horizontal asymptotes can actually be crossed through.
What?
Huh?
Vertical asymptotes cannot. You don't remember what I told you last year.
Oh my god.
Vertical asymptotes,
Yes.
the domain x cannot be there, so no point can ever hit a vertical asymptote. Horizontal asymptotes, it's about what's going on at the end behavior. Stuff in the middle, sure, maybe if you want that. Okay, so good question. Good question.
Oh, so that's why D.
That's why D is not true. Okay, good.
Yeah.
Number 78, the degrees are tied, true? Final answer should be
Oh,
negative
oh, I
1/5.
didn't see that the bottom is negative.
Oh, you didn't see that?
You tried to. I told you.
Number 79, as
I'm pulling this
Austin
one up
said,
easily.
the degrees are tied.
Whatever.
So we would check the sign for 4 over square root of 1. But if you plug in a huge positive number, or bigger and bigger positives, that is positive. Over square root of a positive is positive, so this will end up being a positive over a positive, hence positive 4, hence letter C.
There you go. There you go.
Oh my God.
Good.
And then number 80,
Yeah, I agree.
which of the following statements are true?
You lost me there.
For the limit, wouldn't you have to take this function, because it's where everything but 4 and negative 2 are? So everything below 4 is here, everything above 4 is here. We know f of 4 is equal to 8 according to the second part. We take the limit as x goes towards 4 of f of x. We're going to have to factor the top and the bottom. I'm guessing it's x plus 2 and x minus 4 just by what they said. Yep, that works. And then on top I'm going to have plus 8 and minus 4. So as I'm trying to approach 4, can't I cancel out and plug in for my limit? So I end up with 12 over cos 6. The limit is 2, the value is 8. That is okay. That is not a vertical asymptote, the whole, it cancels out. And no, it's not continuous, they don't match up. So the only true one.
Miss D.
No, sorry. It's not continuous.
This happens all the time to me.
Whoa! Good thing Q only wasn't there. Bye, okay, I'll see you Monday. And you want all these guys your Monday? During lunch, come to the camp for tutoring hours and review.
Yeah, those problems happen all the time to me where I'm like, oh yes, this makes perfect sense, and then it's not there.
I think that's true, it's not. And then I cross it out and I'm like, oh, no, it's true. Just make sure you come get it.
Okay. Thank you so much. It should be just like on the top.
Oh, water bottle. Okay, thank you. Is someone have someone to take it? No, but it's okay. I'll carry. Don't still here.
I
No, it's not. It's Rebecca.
That's why those problems are awful. Alright, see ya.
I think one way is right and it's wrong.